Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. A deep dive into large language model and embedding model performance. What to look for in a new model, how it will impact the final result. So what are the challenges solved by the leaderboards? A new technology solves our challenges, and this technology costs money and effort, right? And the leaderboard helps us to decide where to spend our money and the capital and our effort. It introduces us to new concepts that will help us designing better systems, because by creating evaluation harnesses, we will know how to manage our systems better because we can measure it. Anything that you can measure can be managed. Learning them inside out, I mean, learning them deeply will lead to better results. Provide concrete objectives. We have to know, if you have to train a new model or if you want to design a new model, we want to know what is the objective that we are looking for, what is the improvement that we are targeting. These things can lead us to a large improvement, and that is, this particular point is the key driver for most of the developments that you see today in the large language model arena. It helps in decision making, in providing the data to the stakeholders, because at the end of the day, we are going to be answerable to someone, right? Whether it is going to be public, whether it is going to be your own investors, we need some kind of a data for them that which they can understand very easily. And finally, it creates a healthy competition. One of the crucial things about data science, the natural language processing, etc., is that lots and lots of research team, colleges, individuals come in and compete with each other. In the process, actually learn from it, and at the same time develop the overall community or the ecosystem around it. This is one of the key points that the leaderboards and the inbuilt evaluation methods help. So these are the challenges and the solutions which has been created, which get solved. And when we think about the leaderboards, there are lots of leaderboards. Out of that is already hosted in Hugging Face Hub. The most important leaderboards are the MTEB, that is Massive Text Embedding Benchmark, the Real World Annotated Few Short Task, that is RAFT, Open LLM Leaderboard, and Auto Evaluate Leaderboards. So why these many leaderboards? Why not have a single leaderboard? The point here is that each task have their own benchmarks, and each model have different kinds of outputs and inputs, and has to be tested with various kinds of data sets and in a various different ways. So there are it's not a single task or a single evaluation process that we can follow. So that's why there had to be different types of leaderboards. Out of this, we will be primarily concentrating on massive text embedding as well as open LLM leaderboard. We can learn a lot from these two leaderboards itself. I would suggest that you guys can actually take a look at these two leaderboards, that is RAFT and Auto Evaluate. You will get more information, but it will be similar to what we will see in LLM leaderboard and the MTEB. Apart from this, the organizations also create their own harnesses, benchmarks. In fact, Eleuther AI has the famous 4 benchmarks that it has created, and that is the benchmark that OpenLLM Leaderboard uses. And this benchmark has been touted as one of the best one that is available for comparing the large language models. And Hugging Face Hub itself provides an interface to work with the benchmark through its Evaluate library. If you guys are new to Hugging Face Hub, I would suggest that take a look at my various videos that I have created in this particular channel. And I have discussed about the Evaluate library, I have discussed about the transformers. So all of these points have been discussed here. You can take a look at this in this channel. With that said, let me go back to the discussion. So with this kinds of interfaces with the existing automation around Python libraries, a lot of things can be, the benchmark of this large language models can be automated with ease. Now, let us actually dive a little bit deeper into OpenLLM benchmark. The significance. So there are 4 different benchmarks or evaluation processes to rank the text generation or the generative AI LLMs, that is large language models. First is the ARC, that is AI 2 reasoning challenge. It's a science questions that you ask that we get in grade school. So this is one of the things that most of the LLMs can fare well. Hellaswag. So this is one of the common sense test which the state of the art models actually struggle a lot. And multitask accuracy, the MMLU 5 shot. This test contains 57 different tasks ranging from math to law and much more. And all the LLMs are checked, or they are verified with their ability to complete these tasks. And I will be going through further about these tasks and this what is the meaning of this 10 shot, 5 shot, 0 shot, etc. And finally, we have truthful question answering, whether the model is able to truthfully answer to the text generation. So this is one of the key point. If your model is hallucinating most of the time, then how will you know that it will be able to provide you the best answer? So all these kinds of tests actually make a huge amount of difference when new large language models are entering into the competition. So for an example, let me go back to the browser. So recently I had worked with the Google Bard large language model, and I had made the video regarding that. And in that, when I was researching about it, I found that Bard is really good. It's better than GPT 3.5, ChatGPT 3.5, and it is little lesser when compared to ChatGPT 4. So why I am comparing? How can I compare this? Because I can compare this based on the truthful QA. So if you ask the Bard about something that it doesn't know, it will truthfully say it doesn't know. If you compare it with ChatGPT, GPT 3.5 or GPT 4 might start hallucinating without actually telling that it doesn't know, unless you specifically tell that. And then when it comes to multitask accuracy, yes, ChatGPT 3.5, GPT-4 is better, but yeah, Bard is also equally better when comes to these MLU accuracy. In fact, ChatGPT 3.5 is rated at somewhere around 60 to 70% in the range, while Bard is rated more than 70%, and GPT-4 is rated more than Bard. So like this, there is a best way. Like this, these benchmarks are the best way to compare the large language models. And so here comes the important point. The above is only the test selected by OpenLLM Leaderboard, but Eleuther AI has a large number of tasks, almost 200 plus tasks coded already. So this 57 tasks are part of the huge amount of tasks that the large language models have to compete and complete. So these things are you can actually find it out in Eleuther AI's GitHub repo, and you can learn about these tasks in their in this particular markdown page. Finally, Eleuther AI framework can be used with paid LLMs also. So any of the paid LLMs that is coming from Goose AI, TextSynth, OpenAI can be also compared in this with this harnesses. Now you might be wondering, Kamal, I have never heard of TextSynth, I have never heard of Goose AI. So how you actually come across these kinds of information? It comes through a lot of reading multiple areas. So when I do the research, I always think about what kind of challenges the final end customer will face. An end customer is going to be the user, who is user could be a company, an organization which is trying to streamline its automation, or it could be a marketing or supply chain department inside an organization trying to get hold of the data and try to have a faster recovery of their questions and answer it fastly. And what these kinds of use cases will lead is these kinds of benchmarks. And these kinds of benchmarks actually provide you information regarding the various models that is already available in the wild. So that is how I came across these new open source, not open source, TextSynth and Goose AI. The LLMs are not open source. They actually host the open source models, and they give the API access to us. So the model wise, it is already available. But if you have followed all the earlier videos that I have updated on Hugging Face Up in my channel, then you will be knowing that update, loading and getting the model to work itself takes a huge amount of resource. So TechSynth, Goose AI, these are the companies that provide the resources, that is hardware resources, to host these large language models. So in that sense, by themselves they may not have any model. I think Goose AI has their own model. I have to recheck that. But TechSynth, to my knowledge, they host the existing open source large language models. You can take a look at their website for more information. Now, moving forward, I was, talking about this, 10 shot, 5 shot, 0 shot, and 25 shot. So the arc reasoning comes with 25 shot. So what are these things? This particular pictures were taken from the Hugging Face Up blog. Okay, so here you see the few shot sentiment analysis, few shot question answering, few shot SQL generation. So what this few shot means is you give few examples. So you say, for an example, in sentiment analysis, you inform to the large language model that, okay, the tweet is so and so and the sentiment is negative. Again, you give a new tweet and then you give the sentiment. Same way, you continue that, and finally you give a new tweet and you don't give the sentiment, and you ask it to generate, and you see that it generates a correct sentiment based on the examples that you have provided. Same way, if you are going to ask a few short question answering, so you give a couple of text background, you give the question and the answer. So the large language model or the open source model learns from these few examples and then finally answers the question. This way, you don't need to fine tune the model fully. So you can just at the end, when the model is ready, you can just use these examples and start working with them then and there. The same way for the SQL generation also. So these are all the examples that I'm giving. So in case of 25, it will be 25 examples. In case of 5, it will be 5 examples. So this is the number of examples that is required for the model to test before the test is conducted. So these numbers are already fixed. In that way, the models can be compared apple to apple. These inputs, like for an example, if I am going to give one model 3 tweets and another model 30 tweets, and if the second model does best, so it is not an apple to apple comparison, right? Because the first model was given only 3 samples. So that itself is not helping the model. So such kinds of discrepancies can be avoided when the specifications of the samples are decided ahead. So you see here, the LLM is provided with the task description, the example prompts, and the follow-up answers. So this is how the shots, the examples are structured, and at the end, the question or the prompt that we want the LLM to replace included. When you provide more samples, LLM understands the tasks and make the end sequence into account. So all these things are, something that you guys have to understand when you read the papers that you might come across in your future. So you will know what has happened in the when the researchers were working on the large language models, and when someone actually sells you a new or introduces a new large language model, then you will know how to compare it. So now when a new large language model comes, and if someone says that the truthful QA rating of that model is much better, then you will know exactly what that model did well. Right. So this is the point I was, trying to really drill down. How to think about the benchmarks? Because see, the task the test is trying to evaluate is first thing. So that is the most important thing. But does that task score matters for my application? So maybe you are working with a particular application where the truthful QA does not matter. So you are working with an application that depends on ideation. So in ideation, you never want to worry about how truthful the model is. In fact, you want it to be creative. And at that time, you don't want the LLM to be really truthful, right? You want it to, come up with imaginary things. And same way, if you are going to work on a particular LLM that is going to act as an agent, which will have the capability to decide how it is going to do the next task, then it has to have a good common sense that which task will come after the current task. So that kind of knowledge is more important. So you will know the benchmark that you need to concentrate. So your application matters a lot, and understanding your application from the aspect of the problem that needs to be solved is also the key. As I was explaining to you, that you know that there are certain LLMs which solve the problem of multiple tasks. Some solve the problem of reasoning challenges. Some are really good in common sense. So you know the problem that you have, and then you select the models. This is one of the ways you can drill down on the open source models. So tomorrow, if you want to, let us go to the open source model and see the leaderboards, because I have not shown you the leaderboards yet. Let us go to the OpenLLM leaderboard, and you see that whatever I'm explaining here is already provided here. I've just taken this and converted into distilled data that I can share it with you guys. Now you see a lot of models here, and the top model right now is Llama 65 billion, and it is faring well in all the 4 tests that has been provided, and it has an average score of 58.3. Now this is an average score. You don't need to really think about this particular number. You can always go to individual tests right now and decide whether you want to go with that particular model or not. So here we can clearly see that if you want this Llama 65 billion to act as an agent, you can, because it has a good score in 84.2. And such things can be really understood in detail and based on your application. We see there are so many different models. It's not just 1 or 2 models, right? We see, and also when you actually look at these leaderboards, they actually talk about a lot of information apart from the regular whatever test they are going to do. And some of these things, if you go down in the leaderboard, you can see the evaluation queue. So if you are going to have your own large language model, you can actually add the large language model, your own large language model into this, and you can queue it for evaluation. So you need to provide your model name, the revision that you are going to use. This model name is the name of your repo inside the Hugging Face Hub, and what kind of weight you are going to use. And once you do that, you can submit for evaluation. Once the model gets submitted, then it will get included in this particular leaderboard. Now you might be thinking, Kamal, why these models are not having the hellaswag, that is the common sense and the multitask? Then you have to actually think about what these models are meant for doing. So these models are instruction tuned. Primarily these models are instruction tuned. This is stability tuned. So these models will not be capable or will not be ready for such tasks. So they have not been used for this. These kinds of knowledge, trying to understand what these models are capable of, whether to compare it or not. Like you cannot suddenly, if someone says that, okay, let me see whether Bloomsy 3 billion can can act as a good decision maker, and that it cannot be compared in the common sense, that is hellaswag test. So you will immediately know that, okay, we cannot tinker with Bloomsy 3 billion. So like this. But at the same time, if you take a look at the Bloomsy 3 billion for 36, it has a 36.9 score, and instruction to 12 billion has 42.8 score when it comes to the ARC test. But you still see that the ranking wise, it is still below. That is because the reason why the average has been reduced, so that's why it is below. But if you try to change it here, so if you change the you can let me change that. Yeah, now you see that this entire leaderboard has been sorted based on the ARC test. So Cerebrus GPT 111 million is having the lowest value, and when it compared to ARC, we have where it is. We have Llama 13 billion is also doing good. We have stable Vicuna at 48.1, and we have instruction 12B at 42.8. And so like this, you can actually dig deeper into you can do the data analysis itself on this particular series of large language models. This is something that I wanted to discuss with you guys in detail. And now this is all about the initial application. Second is, whenever you are going to fine tune a model, or if you are going to work with different type of data sets, then once you do that fine tuning and work with the data set, you want to know whether that has improved the model or not. So after you do the fine tuning, you invest a lot of resource and time, and if the model is not going to be any better, then why to do the fine tuning? So you need to understand what has gone wrong, right? So these evaluations help us to know whether our activity of improving the model has worked or not worked, whether the data set that we are choosing is helping the model or it is deteriorating the model. And also you think about for a moment, these evaluations are indirectly, they are not directly able to control the data set, but indirectly based on the results of these test results, the data sets that getting chosen for fine tuning or for training the models can be controlled. So this is something that you guys have to understand. Now, this is all with respect to the large language models, generative AI, etc. But what about the embedding models? So you must have heard of, if you have worked with vector stores, you must have already come across similarity search, and you must have already come across the concept of embedding. And also the concept of vector stores you must have come across when your token limit in the ChatGPT or the OpenAI model had exceeded and you wanted to search for an alternate way to give a better context. So embedding models are one of the key breakthroughs in natural language processing. So embedding models also have to be ranked, and they are ranked for their vectors that they return. So these vectors are finally going to be used for various tasks like bytext mining, classification, clustering, retrieval, re-ranking, summarizing, and semantic text similarity. That is STS. Now, let us go to the MTEB browser for a moment. Let us go to the MTEB leaderboard. So if you go to the MTEB leaderboard, just give me a moment. So it might take a little time for these leaderboards to populate. So if there is a blank screen, then give it a refresh. So it will refresh in no time. This MTEB leaderboards, sorry for the disturbance. So the MTEB leaderboard, we can see that this is massive text embedding benchmark. The number of data sets that is used, the number of models that is scored is 58, and the total score, okay, so that has no bearing here, but the number of languages that is involved is 112. So you see, it is not only English. So this embedding is done across the languages in this world, and it is used for various tasks. Like as you can see here, like bytext mining, classification, clustering. So all these are tasks that these embedded vectors are used. And now this is where the interesting point comes in. You see, there is a model called as InstructXL, which is at the top. It is having an average 61.79 score, and the embed vector that is provided, which is 768 in length. The length of the vector is 768. So just to compare, this particular model gives 768 element vectors, while the text embedding ADA, that is OpenAI model, provides 1536, that is 1536 elements vector. And when these vectors are created and used for this classification, clustering, pair classification, re-ranking, retrieval average, etc., on these tasks, InstructXL model has fared really well. It is better than even text embedding ADA 002. Also, we can see InstructXL and InstructorXL large, both are doing really well. Now, when you are going to work, so let us go back to the PDF. As I was telling, that how to think about the model, because these models are going to be depending on your application. So if you are going to work with vector stores, and if you want to work with mainly semantic text similarity, or if you are going to work with retrieval, if you are going to work with clustering, then the best thing, if you go back to the MTEB leaderboard, you can check, okay, which is better. So when it comes to classification, we see text ADA is giving 70, and in case of retrieval, text ADA is giving 49.25. And InstructorXL is little bit better. It's not extremely good, but it is almost close, right? And if you take a look at the re-ranking, both text ADA and InstructorXL are close by. So you see that instead of using text ADA, you can actually use InstructorXL in most of the places. And also, when you are going to use a sentence similarity search, then you can actually use InstructorXL most of the time. Most of us may not be knowing, but there is a limitation also. So when you are going to use such models, it cannot be used with when you are going to integrate it with the different large language model. If you're going to use open source large language models, then you can use the instructor Excel with the embedded dimension of 768. You can link it with the open source model that can read or that can understand this vector. But if you're going to use this 768 vector with text embedding ADA, probably you will not get a good result, because both of the models don't know what is going on. Such things are crucial. Why it is crucial? Why I am saying it is crucial? Because there is something called as re-ranking. In case of sentence transformers, in case of natural language processing, you have to compare two sentences. This is a basic task that is always coming up. You might have to compare two sentences from two different languages, or you might have to compare two different sentences inside the same particular data that is provided to you, to see whether the question, that a particular question or a query that is coming into the model is similar to something that is available inside the corpus or the data that is already available. So in such cases, the comparison can help, and for comparison we can actually use these embedding models, and at that time we can actually use it for re-ranking also, by re-ranking multiple sentences. So if there is going to be 100 sentences inside the data or the corpus that you're having, and if you have a single line of information that is coming from the user, how are you going to not forget about 100 lines? What if you have 100 lines with you and the actual data is in millions of lines? How are you going to compare it? You cannot actually compare each of these 100 with the million lines one by one. It's going to take a lot of time, and it is going to be quadratic in complexity. So when the complexity becomes quadratic, what will happen? The time required for each of the search will become enormous. To avoid such things, there are various algorithms that is already built by the natural language processing community, and it has been implemented in various libraries like transformers libraries, the TXT libraries, the open source libraries that we have been discussing. All these libraries take care of the details that I'm talking about. So you actually don't need to understand how the re-ranking algorithm works or how the pair classification algorithm works. The reason why you don't need to understand this is it has been completely abstracted, and a proper interface or an API has been provided for the user. You might be a developer, you might be an end user who is working on application. For you may not actually need to understand the internal algorithms of this. All you need to understand is which model is doing good. And for that purpose, looking at the benchmark as a way to help you decide, depending on your application, depending on the output that you're looking for, is the best use case for these leaderboards. And as I was telling, I have not actually gone into the Raft leaderboard as well as the auto evaluate leaderboards. Take a look at those leaderboards and see what you can find. Auto evaluate leaderboard is pretty interesting. Just a minute. Just give me a moment. I just want to, let us go to another one leaderboard that I've already kept, that is auto evaluate leaderboard, and now you are going to be blown away. The reason why I'm telling you this is, I'm going to show you the number of metrics that is available inside Hugging Face Up. And all these are the metrics that is available inside the Hugging Face Up. They actually go in almost, to my knowledge, there are 53 different metrics. If I am not wrong, maybe I have forgotten the exact number, but it is in that range. Here it looks actually it is more than 53, so maybe I'm wrong. And you see, all these are various metrics which can be tested on each of the models. So you see this particular leaderboard that you see here actually lists the various tasks that the model has to compete against, and also the data set. If there is a task, you have to have a particular data set that can be used. So all this has been brought into one particular place, and the model is made to compete. So in that way, we can know better how's the model performing. But this is very, very exhaustive. Even to learn all these metrics will take a considerable amount of time. So this is for serious research purpose. But when you are going to work with applications, when you are trying to use these models, it is better to work with leaderboards like MTEB, OpenLLM. That will be more than sufficient for our purpose as a user, as a developer, or an end user who is trying to come up with new solutions. This level of understanding, working with the leaderboards will be more than sufficient. Coming back to the presentation again, so I hope that now you have got a clear idea about the challenges that leaderboards are solving, and how what are the leaderboards that are available that you can look up to. Following that, what are the significance of the benchmark, like OpenLLM benchmark, the MTB benchmark, what some of the examples you might be coming across, the few shot prompting, or single shot prompting, zero shot prompting, etc. You can see an example that I have shown here from the Hugging Face Up blog. And finally, we had a introduction about how to think about these benchmarks, what these benchmarks, what these evaluation metrics can help you to decide. So I believe that you will like this content. Do leave a like and share it with others, because the primary reason why I'm asking to share this particular aspect with your teams, your senior leaders, is that they have to understand how to decide. So sometimes what happens is that they have a very different understanding of a particular metric or a particular large language model, and when that particular large language model is blindly used, the results may not be as per your requirement, or as per the product's requirement or the product's application. So how will you convince the stakeholders, or how will you convince your team members or your managers to invest in that particular large language model, invest in that particular hardware or the resource to run that large language model? So you will need that information, right? Do share it with others. So this information is available for you right here. All you need to do is take it and use it in your particular case, and do share it with your friends who are trying to learn the technology, because they can actually talk easily, learn, go into the details of the models more easily with such kind of a proper guidance. And finally, do subscribe to my channel for further updates on similar kind of videos, not just on the open source models. I also cover the models similar to I covered models similar to the various proprietary models like Bard, the models like ChatGPT, how to interface or integrate these models with your day-to-day life. That also has a separate playlist in my channel. So take a look at those things. I hope that it will be very helpful for you guys. And with that said, I would like to leave with 4 words. This time it's going to be different. So this time it is going to be read, 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 read. With that said, I would like to take the leave. Have a great day. See you.